Now we will see the definition of polynomial. What is the definition? How we can recognize and how we can define the polynomial. So definition of polynomial is an algebraic expression in X of the form Px is equal to a n x to the power n plus a n minus 1 x raised to power n minus 1 a n minus 2 a n minus 2 means the powers are decreasing, highest power to the lowest one, and it will come up to a3 a2 a1. So a2 x raised to power 2 plus a1 x raised to power 1 plus last term is constant, that means a0 x raised to power 0. X raised to power 0 is 1, so we are not writing x raised to power 0. This type of expression is called a polynomial, but where a0, what are the conditions for power and the coefficients? So where a0 is all the coefficients, a0 is the coefficient of constant term, or it is the constant term, and a1 is the coefficient of x, a2 is the coefficient of x square, a2 is the coefficient of x square, and so on up to an. Is all these coefficients are real numbers. Real numbers we studied already. Real numbers means it can be rational, it can be irrational. It can be in the root or it cannot be in the root, any fraction. And one more thing is important. An should not be equal to 0. It should have some number, because if an will be 0, then its degree will become 0. Okay. And these are called a0, a1, a2 are real numbers, and also these are called, as I told you, we can write here also, a0, a1 are the coefficients of x0, x1. Okay, that I'm not writing. An is the coefficient of xn, an minus 1 is the coefficient of an minus 1, and powers of x, this n minus 1, n minus 2 should be a whole number. Power of x, where powers of x is the whole number. That is very important. If the power of x is in a fraction, it is not a polynomial. Powers of x is a whole number. Means 0, 1, 2, 3. So 0 you will not find written 0, x raised to power 0, because you know that x raised to power 0 is always equal to 1. Okay? X raised to power 0 is always equal to 1. Okay? Now one is figuring it out, you can raise your hand. So power of x is a whole number. So these are two things, and n is called its degree, called an algebraic expression written like this is called a polynomial. Okay. So two things only we have to keep in our mind. One thing, the powers should be a whole number. Okay. And this is a polynomial in variable x. Can be in any variable. For example 2x cube, we generally denote by px, qx, rx. Okay. So say for example px is equal to 2x cube minus 4x square plus 5x minus 7 is a polynomial. Is a polynomial, and its degree, highest power, n is called the degree. N is the degree of polynomial. The highest power of x is called the degree of polynomial. So here it is a polynomial of degree 3. If it is written, can you tell me if it is written highest power is the power of x? Here 3. Highest power of x. Highest power of x called degree. Degree is what? Highest power of x. Okay. Degree is the highest highest power of variable. Whichever variable is there, it can be y also. Like another example, we can say that qy is a polynomial of 4x5, 4x raised to the power 5 plus 3x plus 2. It is not necessarily all terms is there. So here it is a polynomial and its degree is 5. Degree is 5. So this is the way of understanding the polynomial. But if it is written uh, in root also, it is a polynomial. Suppose root is on 2 in the coefficient, root 2x cube plus x square minus x is a polynomial. It is a polynomial. Third example is a polynomial. But if the power is not 1 to 3, suppose you have written like 2 root x, so x is to power 1 by 2, root means 1 by 2, plus x square minus x, so it is not a polynomial. It is not a polynomial. So only the thing that we have to check is the power of x is not a polynomial. Correct? So this is our first example where it is a polynomial. Second, it is a polynomial. It is a polynomial. Third and fourth, it is not a polynomial, but it is not a polynomial. So powers. So very simple. We have to check the powers of a polynomial. Okay. Powers we have to check. Then we can say yes, this is a polynomial. Now we have different types of polynomials. Constant polynomial. What is a constant polynomial? constant polynomial is nothing but it is having only constant term. Polynomial of degree 0. A polynomial of degree is 0 is called a constant polynomial. A polynomial of degree 0 of degree 0 is called a constant polynomial. Called a constant polynomial. Degree 0 means x raised to power 0. For example, if I will write px, any number, 2, that means it is 2x raised to power 0. Same thing. So when x0 is not written, means only constant number. So it is a polynomial, but it is also a polynomial, constant polynomial. Like any number means if you have only constant number, it is also called polynomial. Minus 7 by 5 or rx 3 by 4. Only number is there. There is no variable. Then it is called constant polynomial. Then zero polynomial, zero polynomial. Zero polynomial means the constant polynomial is called the zero polynomial. Degree of polynomial is not defined. The degree of the zero polynomial is not defined. No degree. If the polynomial, if the degree of a polynomial is not defined, then it is called zero polynomial. Means then it is called zero polynomial. Zero means only zero. If you have only zero, so when you have zero, we cannot say any degree. What degree is there? We cannot say that. We can put any number, but it will become zero. Suppose you are putting x equal to 5, also this will become zero. In this case, degree is not defined. So it means zero. If only zero is there, that is called zero polynomial. Now already we have defined, but again I am writing degree of a polynomial because we will divide, categorize, or we will classify polynomials on the basis of degree of polynomial. So degree of a polynomial, as I told you, highest power, highest exponent, highest power of a variable in a polynomial. What? Highest power. You have to check which is the highest power. Highest power of highest power of variable in a polynomial is called the degree of the polynomial. Called the degree of a polynomial. So on the basis of degree of polynomial, example, you can write degree of a polynomial in one variable. We can have in one variable or two variable. Degree we can find out in one variable and two variables also there, but we will deal with one variable in your course, but you should know about it. Okay, the highest power of the variable is the degree of the polynomial. So we are taking the example for one variable, how to find the degree of one variable. Then we have seen only one variable. Now we will see two variables, one variable polynomial. For example, for one variable, you know that under root 3 x square plus 3 root 3 x plus 3 is a polynomial of degree highest power of x is square, so of degree 2. Similarly, we can have more examples. One variable, one for example, suppose you have written 4x raised to power 7 plus 3x cube plus 2x square. So it is a polynomial plus 5 is a polynomial of degree 7. So that the degree of polynomial is 7. If you have polynomial in more degree, in more variables, sorry, in two or more variables, if it is in two or more variables, means it is in xy or xyz, two or more variables. It can be in more variables also. But we have, I think, in our course we will deal with one variable only. Okay, but we should know about it. The, the highest in a polynomial, sum of the powers of the variable, each term is taken up. The highest sum so often is called the degree. In this type of polynomial means in a polynomial of, first we will add their powers. In a polynomial of more than one variable. A polynomial of more than one variable, the sum of the powers of the sum of the powers sum of the powers of the variable in each term is taken. First we will take the sum of the powers in each term. In each term is taken up, and the highest sum, whichever sum is the highest, that will be the degree, and the highest sum so often called highest sum so often is called the degree of a polynomial, called the degree of a polynomial. Example, for example, uh, 7x cube minus 4x square y cube plus 3x y square plus 3y plus 9. So here 3, the degree of this term is 3 because the power is only x is there, so 3. And here we will add these two powers, 2 and 3, adding the powers 2 and 3. This 2 and this 3 is added, so 2 plus 3, 5. So here the degree of this term is 2 plus 1, 3, and here 1 only. So which is the highest degree? 5. 5 is the highest degree. Therefore, degree is 5, like this. So this is what when you have more than one variable. It can be 3 variables, 4 variables, but each term, power of the variables of each term should be added and the highest power will be the degree. But we will deal with one variable. So this is on the basis of degree of polynomial on the basis of degree of the polynomial. We can divide the polynomials on the basis of degree of the polynomial and on the basis of terms of the polynomial. Okay, so classification of polynomials. You can say that classification of polynomials on the basis of first on the basis of degree of the polynomial on the basis of degree of a polynomial. On the basis of degree of the polynomial, number one, first monomial, as you have, no, sorry, not monomial not. It is the linear polynomial first on the basis linear polynomial. What is linear polynomial? A polynomial of degree 1 called a linear polynomial. A polynomial of degree 1 of degree 1 is called a linear polynomial. Called a linear polynomial. Degree is 1, only x is involved, and for example, in general, we can write px if px is a polynomial of the type ax plus b. Ax plus b, where a and b are real, a and b are real numbers, and a is not equal to 0. Okay. For example, px is equal to 2x plus 3. 2x plus 3 is a linear polynomial. Qx is equal to, can have only one term also, like under root 2 into x is a linear polynomial. Rx minus 3x minus 2 is a linear polynomial. The power of x should be 1. Okay. Then second type is quadratic polynomial. Quadratic means 2 degrees. quadratic polynomial is the polynomial of degree 2. So quadratic polynomial is defined as a polynomial of a polynomial of degree 2 called a quadratic polynomial. Called a quadratic polynomial. So general form, you can write it general form dx is equal to, it should be in the in type of ax square plus bx plus c. But it can have one term, it can have two term, it can have three term. Here it can have one term and two term only. So for example, can have, but degree should be two. For example, dx is the polynomial of 3x square plus x plus 2. Okay, it is a quadratic polynomial. Qy, it can have two terms also. 3y square minus y, and it can have only one term also, and it can have another variable z also, but only one variable. We are using only one variable at a time, but it can be x, y, and z. Any variable it can be. So it can have z raised to power 2, z square or 4z square, like this. So it can have one term, two term, three term. But here you can see that everywhere degree is what? Degree of px is equal to 2. Here also degree of qy is also 2. And here degree of qz, r, we can take r. Degree of rz also 2. So degree of rz is also 2. So degree 2. Okay. Next, third type is, it has 3 degree, it is called cubic polynomial. Cubic polynomial on the basis of degree. Cubic polynomial. A polynomial of degree, a polynomial of degree 3 is called a cubic polynomial. You can write down, it's called a cubic polynomial. And in general, we can write px is equal to ax cube plus bx square plus cx plus d. It is the standard form where a should not be equal to 0 and a, b, c, d are real numbers that you can write down. Now, examples, we can write many examples, like if we are writing 9x cube, it is also a cubic polynomial. It can have one term, two term, three term, and four term. It can have two terms like qx, 3x, 3x cube plus 2x, two terms. It can have three terms, it can have four terms, cubic polynomial. And one more you should write, that is called biquadratic polynomial. Biquadratic polynomial. Biquadratic polynomial, a polynomial of degree 4. A polynomial of degree 4 called a biquadratic polynomial, and it can be written as px is equal to a x raised to power 4 plus bx cube bx square plus cx plus e. A should not be equal to 0 and a, b, c, d are real numbers. Example, you can take an example like, for example, bx is equal to 3x to the power 4 plus 4x cube, 3x to the power 4, 4 cube plus 3x square plus 2. This is the part. So now we will see on the basis of number of, next time, number of terms. You can see it has one term, it has two terms, it has how many terms? Two terms, and the last one has four terms. On the basis of their number of terms, we have to define monomial, binomial, and trinomial. Okay, so that we will write next time. So that's all for today.